Hello, good students. Please remember the class rules. Don't skip any part of this video in order to get the full understanding of this question we are about to analyze. The question is 2-point charges are located on the positive x-axis of a coordinate system. Charge Q1 equal to 3.0 nanocoulomb is 2.0 cm from the origin, and charge Q2 equal to minus 7.0 nanocoulomb is 4.0 cm from the origin. What is the total force in magnitude and direction exerted by these two charges on the third charge Q3 equal to 5 nanocoulomb located at the origin? That is the question. So let me tell you something. Most questions in electric field and electric forces that involve coordinates mainly requires a sketch. You have to sketch the question out first before you start solving. You have to get the good or right answer. So nano means 10 raised to power minus 9. So the first thing we're going to do now, we're going to move all these charges to coulomb, from nanocoulomb to coulomb, by multiplying them respectively by 10 raised to power minus 9. 10 raised to power minus 9, 10 raised to power minus 9. This denotes the nanocoulomb. Nano, just use on to denote. So 5 nanocoulomb is 5 times 10 raised to power minus 9 coulomb. So for all, do the same. The next, you sketch out the question. The first thing, they say positive x-axis. So you just draw your x-axis. This is our x-axis. Then this will be, you just be the one to choose your origin. You can choose any point as your origin. But know that if you choose like this, now I make this place my origin. Then I told you before, the distance at the origin is 0 for both x and y. So this point now is the origin of this coordinate system. So we are going to work with the positive x-axis. Positive means the right hand side of the x-axis. That is mean. So you measure 2 cm from the positive side of your x-axis. Then you place your Q1 there, because they say Q1 is located at 2 cm from the origin. Then measure 4 cm from the origin. Place your Q2 there. Remember, Q1 is positive, Q2 is negative from the question. Then the answer, what force will these two charges exert on a third charge, Q3, located at this origin? So that's why I place my Q3 here at the origin. So next, how will this plus react to this plus? So this plus is going to repel this charge to this side, because it's going to be a force because both of them are positive. They'll be repelling. Like charges will repel. So this one will be repelling it onto this side. That's why I said the force on Q3 from Q1, so I call F3, 1. You can see it like this in some textbooks. That's why I just use this notation. And I just said this one is F1, the other one is F2. I just want to use this labeling for now for this question. So the force on Q3 coming from Q1 will be a force of repulsion, which will be repelling the Q3 to the negative x-axis. So you're repelling Q3 to this side. Now let's check for this and this. We're going to solve force between Q1, Q3, or between Q2, Q3, because we're looking at Q3 as the charge in question. Now let's check for the direction of the force. This Q2 is going to be attracting this Q3 towards itself, because it's a negative charge. So unlike charges we attract, so this Q2 will be attracting this Q3 towards the side. That's why this force is going towards the side. Go to this side. So you can see it. This other one is going to this side from Q1. This charge is pushing it to this side, but this side is trying to draw it to itself. So one force is going towards the right hand side, the other going to go towards the left hand side. Another way, one force is going towards the positive x, the other one is going towards the negative x. Remember, left hand side is negative s, right hand side is positive s. At the end of the day, this force moving towards the left hand side will be negative, since it's going to the negative x-axis. The one go to the right hand side will be positive, since it's going to the positive x-axis. Now let's calculate the magnitude of these two forces from Coulomb's law. The distance between 3 and 1, Q3 and Q1, is 2 cm. Is this. Distance between Q3 and Q2 is 4 cm, which is this. Now let's calculate the magnitude of the forces, then add them up in vector way. So our F13 will be KQ1 Q3 divided by, remember from Coulomb's law now, KQ1 Q2 over R square. So I'm going to use these two charges now, Q3 and Q1 for this, whereby the distance between them, square it. So we're going to have this, then we'll have this. Then for F23, we're going to use Q2 and Q3, divided by the distance between Q2 and Q3, we're going to have this. Then the net force, which is total force, now will be, this one is traveling to the left, that's why it's having minus sign. So that means left F1, that's F31. Then this one go to the right, right F32. I mean, both of them were going to the right, both of them will be positive. Assuming both of them were going to the left, both of them will be negative. That's how it is. So we have to observe the magnitude and the direction in which they are going to. So the direction of this one is left, that's why this one is negative, this one is right, positive. So that's kind of convention we use in Cartesian coordinate. So if you resolve this, you're going to have this, then we're going to have this final answer. That means this is the total force. This is total force, and the total force is still negative. That means it's still going towards the left hand side or negative x-axis. That's why I said the total force is this to the negative x-axis, because it's still negative. I think it was positive to be to the positive x-axis or to the right. This one is going to the left now, or negative x-axis. That is the direction is to the negative x-axis. The magnitude is this. Thank you. God bless you.